Channels. Okay, so this just smells of the Go language. The moment I hear channels, this is what Go is known for, although C#, for example, has channels as well that work pretty much the same way. Okay, Nim provides channels used to communicate between threads, and channels links to docs for it. Okay, here's an example with plain threads. Okay, we import the standard OS to get the sleep procedure. We create several variables, create channel to send and receive strings. So we call it com channel. It's a channel type of string, okay? And then we create a sender thread and receiver thread. So both sender and receiver, they will basically execute a procedure that doesn't take any arguments, I presume. That's what we learned last time. And then we have the send message procedure that sleeps for half a second and then sends the message that goes com channel, send hi, okay? And then we have receive message, block on the channel waiting for output, let message, create a message. Oh, we're basically going to wait for the message to receive the message and then echo it. Okay, very important. Channels must be opened before they can be used. Okay, so we open our channel, we create the sender thread, and we provide it with send message. So I already know that this needs that label thread, the same as this needs a label thread. And then we just wait for them to finish. So we should have, from what I learned about channels in Go, the other one printing. And we should have a situation where this will just send things. Okay, this will just send a message as fast as it can. Also possibly depends if the channel is buffered or not. In this case, I assume that we just create a non-buffered channel so it can just, let's see, hold one message. So if somebody else sent a message and nobody received it yet, this will basically wait until there's room in the channel to pass on next message. While receive executed, also immediately, it will just go here and wait and wait and wait and wait until some other thread calls that send message. Okay? And then it's going to receive it and we can just do something with it. So the nice thing about it is that, we can just have normal variable. We just get a string that we can operate on, do stuff with, and we should be, safe from threads. We don't have to deal with any threads, like that. We can just use that channel to send message between the threads without complicated logic or something. Although channels can complicate things on their own, especially when you're waiting for something before it will send or whatever. So let's see if it works. Let's see. I need to prove it works. So we paste it, we save it, and when we run it, it just says hi. So that's good. After that half a second, we enter, bam. So that was the half a second. So we can do echo waiting, and then we do echo gonna send now. Okay. So that will be the sender. Okay. We'll just say that it's a sender saying that, and it's gonna say hi. While here we're gonna do echo receiver says waiting for a message. Okay. It'll echo. And then we do that and we just print the message. Just do this thing to make it. So let's see if it actually happens in that way. So sender says waiting. And at the same time, receiver says waiting for the message. So the sender was waiting before this time. We have the 500 milliseconds. While on the other thread, the receiver is already waiting for it. Then the sender is like, hey, I'm going to send a message now. While this whole time, the receiver was already here. It was waiting for a message. And then when the sender is going to send it, then receiver instantly gets it and bam, I can say hi. I really like it. And at the end, we just join threads to make sure that everything's going to get executed. We don't have any, dangling threads here and there. I presume the language would just clean them up, but this way we can actually make sure that this whole thing is going to get executed before we get to the end of the program and the whole thing just stops. Because if I'll comment it out, I presume that when I run it, we're maybe gonna see one message and then everything ends. Enter. Yep, sender waiting twice and just dying. So it's as if we got bugs. Yep. Okay. Well, with this, we should have no double waits. Perfect. Okay. Things work as we'd expect them. So what else can we learn about channels? Usually channels are created as global variables. That means you must follow a certain procedure if you wish to manually allocate shared memory for channels. Follow a certain procedure. What's going on here? Passing channels safely. Note that when passing objects to procedures on another thread by pointer, for example through a thread's argument, objects created using the default allocator will use thread local garbage collected managed memory. Thus, it is generally safer to store channel objects in global variables, as in above example, in which case they will use a process-wide, thread-safe shared heap. Okay, I understand. However, it is possible to manually allocate shared memory for channels using system.alloc_shared. No thank you, I'm not at that level yet, but yeah, basically what happened here, we had that, this is one of the main files that actually starts the threads. So here we can basically create a channel all the way up here, not somewhere within some kind of procedure where it would, after procedure finishes, get garbage collected. Okay, so we have next example, the same example using the higher level spawn. Okay, so here we're using that threadpool, which again got deprecated. So we do that. We create our channel again as a global variable, and we just have sleep, send it, receive, send it, and then we just use the spawn to spawn those threads without all those shenanigans with create, thread, and whatever. We just sync them up here, and that's it. So yeah, pretty simple to have communication between threads, I'd say. Very simple. I like it. Note that all messages are deep copied when sent. Okay, so yes, when we send something, in this case it's just string. So if we had sent that string, let's say from here, when we created it and sent it over here, we just made a copy of it. We didn't, when we modify it here or whatever, that message, it won't be sent back to where it came from. The same with objects, it will be just a copy, not over reference, copy of absolutely everything. That's why they say deep copy. That's good. That means, the different threads won't be affecting each other. Channels can be used in a non-blocking way as follows. So while true, we check com channel, try to receive. So I guess it will just check if it's possible to receive, and tried. If tried, oh, look at that. It returns an object that says if data is available, and if that data was actually available, it has the message. If it wasn't that available, it would be just set to false. Okay, this is very simple. You can just keep checking, and if it works, you just receive it. So yeah, this is very pleasant. And when a channel is opened, it can be set with a maximum number of items. Exactly. So this is basically our max of 10 items in channel. So this is suddenly a buffer channel. The default is set to 0, which means unlimited queue size. Oh, so it is unlimited queue size. When the channel size is limited, new sends will be blocked if there is not enough space. Okay, so in something like Go, the unbuffered channel will be open with 1, while nim by default set it to 0, so you can just keep shoving messages into it. It'll be queued up. So you just need to be careful not to put too much without having enough processing. Okay, makes sense. So this way will be non-blocking at all times. Very cool. When the channel size is limited, new sends will be blocked if there is not enough space. You can use the try_send function instead, which returns immediately with a ball representing success of the operation. Okay, so we can basically have equivalent of try_send, and if it succeeded, we'll get it true. If not, we'll know that the message didn't send yet. Okay, I really like that implementation of channels. I'm sure there's a little bit more to it, but so far, very, very straightforward to send data between different threads. Awesome.